Hi guys, and welcome to this video where we're going to look at Unit 2 and we're looking at this second independent task. Okay, so these are the 5 topics you had in this booklet. So we have binomial distribution, we have data interpretation, particularly histograms, probability distributions, hypothesis testing, and Poisson distribution. Okay, so you should have already had a go at these 5 questions here. And you should have, again, like normal, gone through and found the level of support that you needed. Okay, make sure you are making a note of what level you are. Okay, because remember, if you're getting like a level 3 or level 4, you're looking at a section or topic where you require a lot of extra work. Okay, so let's say, for example, on hypothesis testing, you had to go and ask your teacher. Okay, then that's a big topic that you need to go away and revisit. Okay. So let's go through the answers now, okay? So for question 1, we got binomial distribution. We got an archer hits a bullseye with a probability of 0.6. She shoots 20 arrows, okay? Now that's the 2 bits that are telling me that it's a binomial distribution. Okay, I've got an N and I've got a P, okay? So straight away, before I even read the next part of the question, there's nothing defined, okay? There's no letters or anything like that. So my first thing needs to be let X. Okay, so in this case, I'm going to let X be the number of arrows hit out of 20. Okay, so I can write my distribution out. So X is binomially distributed 20, 0.6. Now I've got my distribution set, I can go into the questions. So the first one says, find the probability that she hits the bullseye at least 50%. Okay, so there's no number, but it does say 50%. So if she's going to shoot 20 arrows, 50% would be 10 arrows. Okay, so I'm looking at the probability of being at least. Okay, now we need to get used to wordings and stuff in binomials. Now, at least is going to be greater than or equal to. Okay, and I'm going to calculate this. Now, I can't do this straight away in my calculator because we have commutative and it needs to be less than or equal to. Okay, so it's going to be 1 minus because it's greater than, and it's going to be less than or equal to 9 in this case. And from here, I'm going to go to my calculator. So if I type this in my calculator with my distribution, I get 0.1275. Remember, we work with 4 decimal places. And then that's going to give me 0.8725 as my final answer. Okay, now for the next bit, okay, I get told an extra bit of information now. I can now get told that she shoots 12 sets of these 20 arrows. Okay, so I'm looking at a new distribution now. I'm not looking at the number of arrows they hit. I'm thinking about the number of sets that I'm dealing with. Okay, so I want to find the probability that she hits the bullseye at least 50 times, which I've just done. Okay, of her arrows of 7 out of 12 sets. Okay, so I've got to write a new distribution here. That's what's important for me to do. Okay, so as I said, we're going to need a new distribution here. Okay, so in this case, I'm now talking about the number of sets. Okay, so I need a new letter if I need a new distribution. So I'm going to do let Y. Okay, so I'm now talking about the number of sets. So I'm going to do the number of sets out of 20. Now I'm going to include the other bit of information because I'm talking about when they hit the bullseye at least 50%. Okay, out of, sorry, not 20, not 20, 12 sets. You should do an issue. There you go. So we change that to 12. She hits the bullseye. %50 of the time. Okay, so I can write my new distribution. Y is going to be, again, binomially distributed, 12, and the probability is going to be the probability I found here. Okay, because that's the probability that she does hit it 50% of the time, okay, in one set. So that's what my probability is going to be for every set now. Okay, so for part B, I want the probability she hits it 7 out of the 12. So I want exactly 7. So I'm going to look at Y equals 7. Now, just rule of thumb for an exam, if we're doing an equals to, so we're looking at a PD function, okay, use your formula. Okay, so it's going to be 12 choose 7. Then my probability 0.8725 all to the power 7 times by 1 minus, which would be 0.1275 all to the power of n minus x, so the power of 5 in this case. Okay, and I type that in, it's going to give me 0.0103 to 4 decimal places. Okay, so if you've got an equals 2, make sure you try and use the formula as much as possible, especially if it's worth 2 or 3 marks like this one. So next one, find the probability to hit with at least 50% of our arrows in fewer than 6 sets. So again, if I'm thinking about right now, fewer than 6 is going to be less than 6. Okay, again, that's not, although it's less than, it's not less than or equal to, so I need to change it. So it'll be less than or equal to 5. And again, I'm just going to go to my calculator for this, and I'm going to round it to 4 decimal places. Now you'll notice it's a really, really small number. Okay, if you wanted to write a few more decimal places, that would be completely fine as well. Okay, so for the next one, we've got histograms. Okay, so very similar to how they work from GCSE. Let's remember that my frequency density, okay, is my frequency divided by my class width. Okay, that's what it is from GCSE, and it still stays the same now. Okay, and remember, frequency density is what we plot up the y-axis in this case. So this partially complete histogram shows the time in minutes that passengers were delayed at an airport. Okay, so I've got it here. It's not completed, is it? But we can complete it. The first thing is copy and complete the table. So I'm just going to do it on here instead, but I'll write some of my workings down the bottom. Okay, so to get frequency, if I work backwards, frequency is just your area of your bar. Okay, it's my length times my width. So I've got the first one, but I don't have the second bar, which goes across 20. Okay, so if I'm looking at this second one, so 20 to 30, if I'm looking at this gap here, okay, I go across 10, so my class width is 10. I've got a height of 1, so times together is going to give me a frequency of 10. So my 10 is going to go by here. And I'm going to repeat that for each of the other ones. So the next one I've got I'm missing is 40 to 50. Okay, now 40 to 50 has got a class width of 10. Okay, but the height, okay, only goes up. So now if you look, I've got 5 boxes, so every box is worth 0.2. So I've got 0.2, 0.4, 0.6, and then half a box, so that'd be 0.7. Okay, which is going to give me 7 overall. And then I can complete the same kind of like thinking for the last one. This one instead goes across 20 because it's 50 to 70. And it's got a height of 0.3. So I'm going to get 6. Let me put those two into my grid like so. And there's that first question done. The next one, I need to copy and complete the histogram, okay? Now, let's think about what sections I've got. I'm going to tick them off, okay? I've got the first one plotted. I've got the second one plotted. I don't have this one. I don't have the next one, but I've got the last two. Okay, so I need to replot these two middle ones by here. Okay, so I'm going to look again at those two separately, and we're going to calculate, for example, what's the frequency density. Okay, because I need to know what the height is. Now, frequency density should be the frequency, which in the first case is 15, divided by the class width. So it goes from 30 to 35, so that's a 3. So my first bar is only going to go up to 3. Okay, now let's do the same for the next one. I've got 35 to 40, and I got my frequency density. My frequency is 25, my class width is 5, this is going to have a height of 5, okay? Now, usual things, okay, you should be using a ruler and pencil, okay? I'm going to try my best with my trackpad to have a go at this, so I go down by here. Now, going across, I'm actually going to go across half a box, so I need to only go to about there. I'm going to go straight down from there. Okay, so that's my first one. Second one, I'll do a slightly different color. I'm going to keep going, but I need to go all the way up to 5, which would be, if this is 4, 1, 2, 3, 4, 5, always the top of my chart it's going to be. Okay, I'm going to do the same for this side. I'm going to go all the way up. And I'm going to join them up. And then there's my second bar. Okay, obviously you should be using a ruler and pencil, but we can get a gist of what that looks like now. Okay, so I'm going to rub out my shaded bits. In fact, not because it's going to delete everything. See it there. Right, so that's how we draw them. So the next one, estimate the number of passengers who were delayed between 25 and 38 minutes. Okay, now this is where we got to be careful because I don't want all of the bars. Okay, so for example, for the first one, let's think about what 25 is. 25 is here. That would be 25 in the middle. Okay, and 38 would be about here. That's what 38 would be. Okay, so I want part of this green bar as well. So let's think about one. I need to know what this little first pink section is. I need all of the blue section, the blue section, and I only need a little bit of this green part. Okay, so I need to find out what those areas are individually. So the first one, I'm just going to do base times height every time. I go from 25 to 30, that's a base of 5, and I've got a height in this case of this bar of 1. So that would be this first pink section. Now I need all of the blue one. Okay, now the blue one goes across 5 because it goes up to 35, and it's got a height of 3. And I'm going to do the section I need from here. Now this is 35 by here. I need to get to 38, so I've got to cross another 3, and this bar goes up to 5. So I'm looking at each of the sections individually. I'm just timing them, I'm going to add them all together. Okay, so I get 5, 15, and 15. Okay, so I'm going to add them all together. That's going to give me 35 passengers in total. Okay, so the next one, we've got probability distributions. Okay, so I've got a biased coin. It's tossed until a heads appears, or until it's tossed 4 times. Probability to get a heads is 2/3. Okay, so it's not normal half that we're used to. Write a probability distribution for S. So this is a table that I need. Okay, so I'm going to end up with a table where I've got S, and I've got the probabilities of S underneath. So first of all, let's think about what values this can take. Okay. So I'm going to toss the coin until I get a heads. Okay, so I could get a heads on the first time, which means I've tossed it once. Okay, or I could get it on the second time, or I could get it on the third time, or I could get it on the 4th time, or my game ends because I've tossed it 4 times. Okay, so I've got these 4 things to calculate. Okay, so the first thing is going to be the probability of getting a heads on the first time. So S equals 1. Okay, getting a heads on the first time is just 2/3. Okay, so I'm going to put 2/3 by here. Okay, the probability that S equals 2 for me getting a heads on the second time. Okay, the first time I need to not get a heads. So the probability of a heads is 2/3. Probability of not a heads would be 1/3, and then I'm going to get a heads. Okay, so that is going to give me 2/9. Okay, then I'm going to do probability of S equals 3. So again, that's the same thing. I'm going to need, it's not a heads, so 1/3, then another not a heads, and then a heads. Okay, and if I times them, I get 2/27. And the final one, we kind of got 2 ways to figure this last box out. Okay, the first way is that all these probabilities should make 1, and that's probably going to be the easier method. Okay, so if I take all of these away from 1, I end up with 1/27. Okay, which is fine, but I want to show you why it's that. Okay, because what lots of people do, okay, to toss the coin 4 times, there's actually 2 options here. The first option is I get a heads, so that's not a heads, not a heads, not a heads on the 3rd go, and then a heads. Or my game ends after 4 times. So I could also just get no heads at all, and the game will still end. So I've got 1/3 times 1/3 times 1/3 times 1/3. Okay, so I've actually got 2 options here to work with, and that still gives me 1/27. Okay, so I can use the factor adds up to 1, but this is the reason behind it, because otherwise people just do this first option here, and they forget about this second option. Right, now I've got my table. What it wants is the probability that S is greater than 2. Okay, probability that S is greater than 2 is the probability that S equals 3, or probability that S equals 4. So I'm simply going to add up the 2 probabilities here. So I've got 2/27 plus 1/27, and I'm going to add them up. Okay, that gives me 3/27, or a 9th, if I simplify it down. Okay, so for the next one, we've got hypothesis test. Now, there is an extra page on the other side, okay? So there's quite a lot that needs to be done here. So let's make sure we understand what the question is. I've got the proportion of defective items, articles in a certain manufacture process has been formed from long experience of 0 to be 0.1. So that's my P. Okay, a random sample of 50, so that's my N. Okay, articles was taken in order to monitor the production. The number of defective items were recorded. So first of all, usual thing, there's no letter, let's make a letter. Okay, so I'm going to make my variable. So let X be the number of defective articles. Out of 50. So I can write my distribution. So that means X is binomially distributed 50, 0.1. And then what I want to do, so use a 5% significance level to find a critical region. So I'm finding critical regions here, which can be a little bit harder for a two-tailed test. Just telling me what kind of test it is. So remember, the next kind of step for me to do always is to write out my hypotheses. Okay, H0 is what is currently in place. So that means the probability is 0.1. And in this case, they told me it's two-tailed, so I know it's not equals 2. Okay, if it doesn't say exactly, we do need to make sure we are picking the correct one as we go through it. Okay, now it wants me to find the critical region. Okay, so I'm going to use the tables in my calculator, or you can use the physical tables if you prefer. Okay, now what they also say, and this is a slightly different thing about this question, the probability of each tail should be as near 2.5% as possible. Okay, so if I'm looking at the bottom end, so from tables, I'm going to write this down. Okay, if I go to the list function and I just go like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's go to like 15, for example. Okay, I put the n is 50, p is 0.1. Okay, and I'm going to find out what the probabilities are. Now you'll notice, okay, probability that x is less than or equal to 0, so just equal to 0, gives me 0.0052, and then the probability that x is less than or equal to 1 gives me 0.0338. Okay, now normally I just look at the first one that would be under 2.5%, but this one, because the criteria it tells me has to be as near it as possible, I got to think about which one of these is as near as possible. Okay, and that would be this one. Okay, now that's the bottom end of the tail. I also need to look at the top end of the tail. Okay, now because I'm doing because my tables give me less than or equal to, I need to do some 1 minus in here. Now, what we end up with, if I look at the probability of x being greater than or equal to 9, for example, that would be 1 minus the probability that x is less than or equal to 8, okay, which comes out as 0.0579. And if I do the same for the one above it, so 10, I got 1 minus the probability that x is less than or equal to 9. Okay, that comes out as 0.0245. Okay, so this one is now the one that's closest. So I've got two critical regions here. So my critical regions are, I said it's x is less than or equal to 1, or x is greater than or equal to 10. Those are the two that I've ended up with here. Okay, now for these second two, I did have to go like back and forth and do some sums. Okay, but we just need to be pretty patient and efficient with those. What can help is using the physical tables from your stats booklets. Okay, that can speed up this process instead of you going back and forth in your calculator. So, part B says, I'm actually going to do this underneath it just so we can keep this bit together, and then we'll do part C on the next slide. Part B, state the actual significance level for the test above. Okay, so although we technically used 5%, we halved it and looked at 2.5. I'm actually using these two values. Okay, so these are the two probabilities that I've got. So I've got 0.0338. So I'm going to add 0.0245. Okay, so if I add up those two, I get 0.0583. So the actual significance level I'm using is 5.83%. Okay, I'm not actually using 5%, I've used 5.83% because I tried to get it as close to 0.25 as possible. Okay, so now we've got part C to do, okay, which changes things up a little bit. Another sample of 20. So I'm going to need a new letter. I've now got n is 20. My p stays the same. My p is still 0.1. Was taken at a later date. 4 articles, so that's my observed, were found to be defective. Test a 10% significance level whether or not there's evidence that the proportion of defects has increased. Okay, so remember what I said about finding out what you want to do for your H1, so your alternate hypotheses. this is what's going to tell me what to do. Okay, so I've got a few things to do here. So the first thing I need to do is I need a new letter because my x was out of 20, it's out of 50, and I now want it out of 50. So I need a new letter. So let y equal the number of defective items out of 20. Okay, so I've got y is binary distributed with 20 and 0.1. Okay, that's my first part to do. Okay, the second part I need to do is do my hypotheses. So H0 is that the probability is 0.1. Okay, and H1, in this case, they're doing the fact that it's increased, so greater than 0.1. Okay, now I'm going to use p-value here. I think it's a little bit easier with binomial, and they're doing critical region. Okay, so what I'm going to do is I'm testing for greater than. Okay, so I'm going to look at greater than or equal to my observed value, which is 4. Okay, and I'm going to say when H0 is true. So I'm going to use the probability 0.1. Okay, now again, I can't do this in my calculator with binomial, so I'm going to do 1 minus probability of x being less than or equal to 4. Oh, sorry, less than or equal to 3. Let me change that. When H0 is true. And I'm going to calculate that. Okay, so that comes out as 0.1330. Okay, now when we get to this point, I'm going to compare it to my significance level. Now my sig level is 10%, which is 0.1. Okay, so I'm going to compare these two. Okay, now this is bigger than 0.1, isn't it? Okay, now if it's bigger than 0.1, that means I've got insufficient evidence. So insufficient evidence to reject H0. Okay, that's my first bit, and now you must put something in context. Okay, so I'm going to say, so insufficient evidence to suggest, and I'm going to steal the wording from the question. Okay, so the question said, there is evidence that the proportion of defective articles has increased. I'm just going to steal that wording, okay? That's the proportion, suggests the proportion of defective articles has increased. Okay, so I'm stealing the wording from the question so that I'm making sure I'm writing as accurate as I possibly can. Okay, that's really, really important to make sure we got that extra line at the end, because otherwise you're going to lose a mark. Okay, so we've got one more question to do, and that's on Poisson distribution. Okay, so I've got the lift in a block of flats breaks down at random with a mean rate. Okay, so this one I'm looking at a rate at 3 times per 4 weeks. Okay, this is what's telling me it's Poisson. Okay, although I've told you in terms of the top, okay, that is telling me it's Poisson. So for part A, again, I need to let x be something. Okay, so I've got let x be, again, it's always the number of something when we're doing Poisson binomial. Number of, let's think about what I'm doing, the number of times the lift breaks. Okay, now let's read the question before I do anything else. Find the number of times the lift breaks in 1 week and 1 week. So I want it only in 1 week. Breaks in 1 week. Okay, so that means x must be Poissonally distributed. And again, I need my lambda. Now, the lambda they told me up here is 3 for 4 weeks. So if I want it for 1 week, I'm simply going to divide by 4, which would be 3/4 or 0.75. Okay, make sure you have it in the correct amount of in the correct period. Okay, so the first one is at least 1, so greater than or equal to 1, and it works the same as binomial. That's going to be 1 minus the probability that x is equal to 0. That's the only one that I'm missing. Okay, so 1 minus 0.4724. I've just used my calculator for that, which would be 0.5276. Okay, then I've got part 2, which is going to be something pretty similar. I want exactly twice. Now, again, same with binomial, okay, and Poisson here. If you've got an equals to, use your formula. Okay, so it's e to the minus lambda, so 0.75. That's my 3/4. Then lambda times lambda, 0.75 to the power of x, which is 2, all over x factorial, so 2 factorial. And I'm going to type it in. 0.1329. Okay, now in the last one, in one particular week, the lift broke down twice. Write down the probability that the lift will break down at some point in the next week. Give a reason for your answer. Now, what's important about both binomial and Poisson, okay, is that your events have to be independent. Okay, so I'm going to say as breaks are independent. Okay, what that tells me is basically, it doesn't matter that it's already broke down twice. Okay, that's not affecting whether it's going to break down again. Okay, so if I want to find the probability that it will break down at some point, I'm going to find the probability that x is greater than or equal to 1. That's it breaking down at least once, if not more than once, in the next week. Okay, and we've already done that. We did it up here, so that's 0.5276. That's my final answer. Okay, there's no need for me to think about it already breaking twice. That doesn't affect whether it's going to break down again. Okay, so that's it for this video. Make sure you've marked that and you've done any corrections you need to, and that you've highlighted any topics that you need to go over now, okay? But apart from that, well done so far, and I will see you in the next video.